All right, morning, folks. We're moving along here. All right, so just letting y'all know the grades should be accurate in Canvas now. Basically, they don't go over there until everything is, the due date on it is complete, and I had to go through this weekend and make sure everything was all right. There were a few things out of place, because when it syncs from my math lab, sometimes it just puts things in a strange place, because I got the different categories based on these 1, 2, 3, 4, 5 categories.
Looking sharp, my man.
All right, thanks. What happened to you? I haven't seen you.
Look, I didn't know y'all was doing a virtual thing, because my phone be up on level. And then,
Well, it was a week ago. I had planned and I put it in announcements that I was gonna be here.
yeah.
And then I got somebody call me, where are you at? The guy, that runs over here. So we had that conference, and so I had to, but I didn't do virtual. I just went on, and because in my morning class, went on there because I was on the computer anyway. It was a virtual conference. I mean, I said there were some people that actually showed up, so I took people to read the announcements or whatever. And then in this one, I don't know what happened. I was there, and people were saying, why aren't we having class? And I said, read the announcement. And people couldn't see it. I don't get that. So, but there were certain people that told me they saw it, so I don't get it.
You got a date or something like?
What's that?
You got a date or something?
Yeah, I got a date with some students.
Oh.
It's just a long sleeve shirt.
I know, you ain't got to help. Looking
It's
sharp.
always not much different than usual. This does look a little bit snappier, I guess. All right, so we are going through chapter 3. We're gonna get the rest of it. We did. All right, we're doing 3.3 today, and as I said, I'm not going to encourage anybody to drop because you got to make that decision. If you want some feedback, I'll do it. But the grade should be accurate in Canvas. So that drop date, I think, is tomorrow, but I'm not 100% sure about the time. It might be 4 o'clock or something like that. Anyway, so we're going to get up with 3.3 here. So let's get started on this. Oh, and and just also keep in mind, though, you're going to be able to replace a low test grade with the final exam. So, if you have a bad test grade, you can shoot your average up considerably. So again, I want to go through the little presentation that we got, and then I'll pull some problems out of the back of the book. So 3.3 is sort of how to, it's basically properties. And there's like a handful of properties. And then it can be used to simplify things or put them in another form. And as I said, because I didn't want to make that last test too taxing, the last test will be just on all of chapter 3, the 3.1 and 3.2 included, because you can't really take those things apart. And it didn't make sense to me to put more stuff in that other test that didn't really seem related. So the last test will be everything to do with logarithms. Let's see. So let's get back over there. All right, so properties of logarithms include something called product rule and quotient rule and the power rule. Sounds very similar to exponents, but they are very similar, but they're slightly different. Expand logarithmic expressions and then condense logarithm expressions. Those are really the opposites of one another, and then use the change of base property. And when we use the change of base property, it allows us to rewrite things in particular base and then evaluate and approximate things. So the product rule is essentially like this. If we have a log with a given base of m and n, in other words, they're being multiplied times one another, then we can expand it by writing it as the log with the same base of m plus the log of base b with n. All right, see how that works? This in my Math 097 class in chapter 5, there's a product rule over there, and it's basically if you're multiplying like bases, you add the exponents. Well, notice here the same pattern holds. If you've got the logarithm of m times n, then it's equal to the logarithm of m plus the logarithm of n. So a multiplication and addition have that same correlation. So let's look at an example. So if we have the product of 7 times 11, then it can be broken into the product of, it can be broken into the sum of the same base, log of 6 of 7 plus the log 6 of 11. So if you went ahead and I don't have a log base of 6 on there, that's right. Please don't know how to use it. But anyway, I was just going to show you that it works, but can't do that with that. I can do it with it. Well, on the second one, I can't really because it's got an X in it. Anyway, so the same thing, if we have the log 100 of x, then we can break it as the log of 100. And remember that without the base there, that means log base 10, common log, plus the log of x. Now, they take this right here and they evaluate that. Now, let me just show you why that's happening. In case you have some questions about it, because I would have questions about it. All right. Log of 100, in other words, remember, that is log base 10 of 100. So we have to supply the power to know what that means. So that means 2 because cos 10 to the second. All right, so what does that mean then? When we take the log of 100, then that simply means 2. Okay, that's equal to 2. That log right there is equal to 2. So we can replace that with 2. Right, so it becomes even simpler. And then the other one is just still the log of x, because we can't really evaluate that because we don't know what x is. Now, that's all we can do. Now, the next one is called the quotient rule. And notice that the quotient rule is used when we've got division, right? The log base b of m over n, and remember the fraction means division. Then that's log base b of m minus log base b of n. All right? All right, so division, subtraction, remember, in exponents, if you're dividing like bases, then you subtract the exponent in the denominator from the exponent in the numerator. So it's got a very similar relationship that division corresponds to subtraction. Because remember, with addition and multiplication, those two things are commutative. In other words, the order doesn't matter, but with subtraction and division, the order is important because 6 divided by 3 is different than 3 divided by 6. Likewise, 5 minus 10 minus 5 is different than 5 minus 10. So these two things make up division, subtraction. That's why they call it the quotient rule. So if we've got the log of base 8, 23 over x, okay, so the first one is going to be the numerator, the log base 8 of 23 minus the log base 8 of x. Right? Nothing really we can simplify there. Now, the other one is log of e to the 5 over 11. That's our fraction. That's our division. So that's, and this is, remember, that's the natural log, and it's just ln. ln of e to the 5th minus ln of 11. Now, again, the same thing is happening that happened over here. Because these two things essentially undo one another. Say the ln of e, well, it's just going to be the power. So that's what happens there. So this right here evaluates to 5, so that's 5 minus ln of 11. And generally, what ends up happening here is this is easier to evaluate sometimes than what this is. Okay, so that's the purpose of doing it. And then you got a power rule. So there's a power rule when you're dealing with exponents. Log b of m to the m to the p power is equal to p log of b to the m. So what happens to the power? It comes out front and becomes a multiplier. Becomes a multiplier. Power there comes out and becomes a multiplier. And then generally that makes this one easier to evaluate. Multiply by p. They have a little synopsis on these each. The logarithm of the number with an exponent is the product of the exponent and the logarithm of that number. So let's look at a few examples. Log base 6 of 3 to the 9th. Well, to use the power rule, the 9 comes out front and multiplies log 6 of 3. Now you got to remember when you've got a radical that translates as a rational exponent, remember? So, third root of x. All right, well, what does that mean? It means x to the 1/3. And the general rule for that is just the nth root of x is equal to x to the 1/n. So radicals relate to rational exponents. So the base, or the index of the radical becomes the denominator of the exponent. There's another one, we may need it later, but I'm going to put this here. Well, if there's a power there, or if it's actually power on the outside. Either one of these two things mean the same thing. You can write that in this way. Okay, so those two things right there are the properties for rational exponents in regard to radicals. So for the most part, it helps us to recognize those, because it's going to help us to put put things in the exponential form. All right. So on this one, ln of the third root of x is equal to the ln of x to the 1/3. That's where that comes from, that property is equal to, and then that power comes in front as a multiplier, 1/3 times the ln of x. And it doesn't matter what's inside the mount there. Okay, that's x plus 4 squared. Well, it can come out as a multiplier. Just as a general kind of a little bit of word of advice. Well, about why, word about why this is useful. Because if we multiply that out, you got to square out a binomial, and then when you evaluate it, it could be a big pain in the neck. But multiplying this out in front, you know, you can evaluate that and just multiply by 2, get to the same point. All right, so let's just sum these up and we'll try to put them to use. All right, the log base b of m times m is equal to the log base b of m plus the log base b of n. Okay, that's the product rule. The quotient rule is the log of that fractional m over n is equal to the log base b of m minus the log base b of the n. Quotient rule. And then the power rule is the log of the base b m to a certain power. The power comes out front as a multiplier. All right, so let's use the logarithmic properties to expand the expression as much as we can. We got the log base b of x to the 4th cube root of y. Well, the first thing is to use this thing here, okay? Because we don't want to have that radical in there because we need to have it written as a power for this to go smoothly. So the cube root of y is y to the 1/3. All right. Now, what's being multiplied? Well, we're multiplying in there the x to the 4th and the y to the 1/3. So we can break it apart sumwise. Log base b x to the 4th plus log base b y to the 1/3. Now this one here, the first one has a power. So we can use the power rule. It has an exponent on the axis of 4. So the 4 comes in front as a multiplier. log base b of x. And this one does too. It's got the 1/3, so it comes in the front as a 1/3 times log b of y. All right? Any questions about that? That one allows us to use both the product rule and the power rule, or we need to use it. Like I said, is they want you to expand as much as possible. So that's what they mean. Apply as many rules as you can. And from that point, there's not anything that you can really do to expand it. Now, we will see a little bit later about the condensation process. In other words, they may give us one like the one, the answer there, and ask us to condense it to go the other way. All right. So let's go on now. So there's a little bit more expansion. So we got log base 5 of the square root of x over 25y cubed, which is equal to log base 5. And we rewrite the the radical with the rational exponent. So the square root of x becomes x to the 1/2. That's important to do that here because it's going to mean that we get to use the power rule, and without that in that position, you won't be able to do it. So don't forget that, because if you got a radical in there, change it to rational expression power of rational expression. Log base 5 x to the 1/2. This is a quotient rule thing because we've got this one divided by this one, and we follow the order. The numerator becomes, and this is, I always forget this, but there's actually names for when you're subtracting. This is called, like in division, since there's actually a name. There's quotient is the result of the division, and they have a couple other names. But I always just, since it's fraction, just call it numerator and denominator. So what comes first is the numerator. And actually in subtraction, there's actually names for these two things. I just don't know what they are and don't use them. Something like the subtrahend or whatever. I've never heard of anybody ever use them. So log base 5 of x to the 1/2 power minus log base 5 of 25y cubed. Both of these have powers now. All right. Now, here's the problem is this one right here is not finished because 25 times y cubed can be broken into a sum using the product rule. All right. So we're just going to leave this one right here for the time being. All right. And remember, this can be broken up now as 25. Let me just show you. What's going on? Page 5. 25y. All right, so they're going to break it apart as the log 5 of 25 plus the log of y cubed. What's the base 5? I keep leaving that part out, but all right. So now that's how they get that, just in case you're wondering. All right, now you're subtracting both of those. And this is one of those things, when I go through the basic algebra, oftentimes students forget this because when you're subtracting something and it's in parentheses, you got to apply the negative sign to all the things there on the right that you're subtracting. You can't forget and just subtract the first one. You got to subtract both of them. So this one here, half comes out in front. Log base 5 is x minus the 2 log base 5 to the 5. Remember, 5 squared was 25, so they condensed it essentially into 5 squared. And then the negative or positive is negative. And that 3 comes down to multiply log 5 to the 1. So, what did they do here? Okay. So 1/2 log base 5x stays the same. This one stays the same. How do you think they get that too? Because log base 5 of 5 is 1. That's the property we looked at, I believe it was last week on Thursday. We take a base, a log base of anything, and then bring that in, then these two things really just undo one another. This 5 undoes that 5, and that's 1. Just in case you don't remember. I'll show you where it's coming from. That was this one here. See, if the base and the input are the same, then that's 1. And why is that? Because anything that results in itself or anything brought to the first power is 1. It's just that base. Okay? It's just essentially a new one logarithm. But essentially means then over here we have log 5 that's equal to 1 because 5 to the first power is equal to 5. You just generally don't see it written as 5 to the first power. Okay, so that's how that got like that. We're using the rule over there. That's that one. And so that's 1. And this 2 is coming back and multiplying. It's 2 times 1 is 2. Or negative 2 times 1 is negative 2. So there we go. Any question about that one? I know that one is getting up there, but they're using, even though they're using this as an example of the quotient rule, they're also bringing in the power rule and the product rule as well. All right, and so condensing, then obviously we can go back the other way. All right, the log of m plus the log of n is equal to the log of m times n. The log of m minus the log of n is equal to the log of m over n. It's going backwards. And then p times the log of m is equal to the log of m to the p power. Right as a single logarithm. In other words, we've got log of 25 plus the log of 4. Well, first of all, we can take them and use the product rule to multiply them. So the log of 25 times 4, which is equal to the log of 100. And then 100 can be written as 10 squared. And the log of 10 squared is 2. All Now remember, there's no, when you have no index down there, that means 10. That's the common logarithm. And that's the one that's on here. In case you haven't noticed, like a basic calculator. All right. That's this one right here. So let's just say we put in 100 and take that log, see, it gives us 2. Okay. That's the log base 10. The only other one they've got on here that's readily evident is the natural exponent. These two are by far the most prevalent ones that I've seen. Usually the ones with these other bases, they're not that common. They basically use them in the exercises just to make sure you understand and can see a base and understand that how it works, that it works for any base. But most calculators, if there's a way to evaluate a log base 3, I couldn't tell you how to do it without going and doing a little bit of researching, because it may not be able to do it, or it may be buried somewhere that you have to do something. All right, y'all okay? All right, so we got another one here. Log of 7x plus 6 minus the log of x. So we got negative there. So the negative is, or the subtraction sign has got the log x on the right there. So that's going to be in the denominator. And then this part is in the numerator, using the product in the quotient rule. See? Got to get that order right. Well, there we go. So the second one goes in the denominator, the first one goes in the numerator. Numerator, denominator. It does matter with division, just like it matters in subtraction. So not anything else we can really do with that one. That's the common logarithm. The next one is the natural logarithm. We've got 2 ln x plus 1/3 ln of x plus 5. So this is what we're evaluating here. Okay, and we're going to condense it. In other words, because there's a plus between these two, we can use the multiplication to do this. Now, one of the things that they do first is they bring the powers up from in front of the exponents and make them powers. So they take the multiplier in front of the logarithm and bring it up and make it a power. So the 2 comes up there, the backwards power rule, plus, and then the 1/3 comes up and it's a power for the x plus 5. Is equal to ln now of x squared, because there's a plus here, times the ln of x plus 5 cubed. And the only other thing you can do is just make this into a cube root. Ln of x squared times ln of the cube root of x plus 5. Any questions about that? How about out there in virtual land? All right, well, let's look at the change of base property. Now, the change of base property is important because it can allow us to evaluate things that we might not otherwise be able to and approximate a solution. And you're going to see that in certain ones of these things. It says for any logarithmic bases a and b and any positive number, all right? So remember that input for the log is going to be positive. So log base b of m is equal to, now notice what they're doing is, they're changing the base and they're taking and putting in the numerator that changed base, It's called A. Log base A of M is in the numerator. And the log of base A of that power, I'm sorry, that base becomes the denominator. And then they've got their wordings that help us. It says the logarithm of M with base B is equal to the logarithm of M with the new base divided by the logarithm of B with that new base. Notice that these bases have to match. Okay? They have to match there. If you change it, you convert it to one new base. So for common logarithms, you know, it would be just log, common log of M over common log B. And then with natural logarithms, natural log of M over natural log of B. All right, so let's look at an example. One more, and then I got something to go through. All right, so the log base 7 of 2506 is equal to the log. And now notice that the base is dropped now because that's the common log. That's log base 10 of 2506 in the numerator divided by the log of that base 7, common log 7. And then how do you find out what that's equal to? Well, and this is why this is useful, because calculator, I wouldn't know how to find the log base 7 key on here. It might be in there. And I see if you got a graphic calculator, those, they may have it in there, it may just be buried, but I don't know. Just because you can use this, it may not be something that's even in there. I don't know. All right. So let's do the denominator first, and I'm going to put it away somewhere. So let's just say I put it at 7 and I get log, and I'm going to put it into our memory, and then I'm going to do the numerator at the log, and then I'm going to divide it by, and say I got 4.02. And again, it's going to be an approximation. So pay attention to what you're asked to round to. Okay, because that's going to be important. They don't say what the log is, but on this, they went out to the hundredths in this case. All right, so we got natural log. You can do the exact same one with natural logs. And there's a natural log key on it.
That's why when I remember it.
So 7. Put it in the memory. And then we'll do 2506. So same thing. Doesn't matter what the log is, you change it to. So it's a very handy tool for evaluating other bases. And I say this, in many cases, it might be the only way to do it, because I said I'm not sure calculators can do it. All right, so let's look at some things here for the last half hour of the class. 4. So just put up here, expand. So the log, base 9 here of 9x. So that's a multiplication one, because these two things can multiply one another 9 times x. So it means log 9 of 9 plus, well, it's 9 of x. Is there anything else we can do there? Yeah, because of this thing here. Okay. When the base and the input to the logarithm match, then that's equal to 1. It doesn't matter what logarithm base it is, if these two things match. All right, so that one's expanded out. Any questions? These are from the book, back to the book. So here's another one that will do quotient rule. 8. So the natural log of 8 of e to the 4th divided by 8. All right, so anything that can change here? Yeah, you can put 4 in front, good. So we're now using the product rule and the power rule. All right. Now, with this one, so there's no base, but because it's understood that it's a natural logarithm, see? Look at number 3 here on the right. So what can that help us do? So that's 4 times 1, right? Okay. The ln and the e undo one another. And essentially, if you don't quite get it, see that's a power of 1 there. So that's why I got 4 times 1, because ln of e to the 1 is just 1. All right on that one? All right, so the power rule. So let's look at another. So that's the natural log of the 7th root of x. So what kind of might you do first? What would we do first? for the exponent, right? Okay. So yeah, we're gonna do the first thing is the ln of x to the 1/7 power. All right. Now, anytime you got a power, remember, you can take it in the power rule. So what do they have these things condensed in? Okay, remember that if it's out here, you can bring it and put it in power, or if it's in power, you can take it out and bring it in front. The doing and the undoing, so to speak. So this is 1/7 ln of x. Okay? See anything else we can do? All right, so all right, first of all, what can we do? Mhm. It's one of the better ones to do first. All right, now we can get rid of that, can't we? The power rule. A good idea to do that first because we can't get to the insides of that quotient until we bring it out front, right? All right, so what else can we do? Quotient rule, right? Now, remember, we gotta multiply whatever comes out of there, right? That's the thing that's important here. We gotta multiply whatever comes out. And remember, this whole thing is gonna be a quotient. All right, so what else can we do? Distribute? Oops, why? Okay. Anything else? I mean, as far as its expansion is concerned, I mean, if we had this and we want to go back the other way, we could, but you know, we're not condensing. So condense. I took the one Okay, let's do one more expansion. All right, so again, we're going to take okay. All right, so now what I'm going to do is there's this thing called, I'll just refresh your memory about it. Let's see. It's actually, I think it's called the power rule for products. In other words, we have, so we got A and B, we use base, and then we got X, and it passes along to each one. And also, if we've got A and B and a quotient, then that applies also, okay? So keep that in mind, that's what we're using now. So that is from my old Math 097. It's in the exponent section where we have properties of exponents. All right, so that's going to be log x to the 1/3 and I'm going to multiply that 4 times 1/3 is 4/3. That's a multiplication, okay? And then 16. All right, so now let's take it and break it into two. Now using the product rule. So that's log a to the 1/3 plus log y to the 4/3 minus log okay. So this can come out as a multiplier, right? This one can come out as a multiplier. Four-thirds log y minus oh, I know what I'm kind of there's something else I can do with this one. Hold on a second. Okay. Let me show you something we can do. All right, 16 can be written as there's a way to simplify this. Oh, you know what? Let me look at it. But I think that's supposed to be 5. I was wondering why it was funny. Wait a second. Stop here. Hold on. What's that? I think that's what it is, and that's why it's because there's one more thing we can simplify. As it stands, there's nothing else we can do there. But I may just go ahead and do it again. I think that's supposed to be and this was Helen. If I was looking. But that's accurate up to there. One thing you have to realize that 16 is 2 to the 4th power. Okay. So log base 2 of 2 to the 4th power gives you 4. And 4 is going to give you, it'll still work. Let me just make sure. 36. Yeah, it's the 5th power. I think it might still work like it is, even with the cube. So this is log base 2, and I wasn't being faithful with them. So let me fix it. So what 16 is 2 to the 4th power. Let's see if this will work for the thirds. I'm not going to go back and do the 5th. That's what it was, but it shouldn't matter for the most part. And this is 4 squared, okay? So what's going to happen is that ends up being a 4 there. So let me just go ahead and fix it. I'm just going to fix it. So this right here would be 4/3 minus 4/3. So just to it works without the 5th. I just that's not me, right? And that's one of the things that causes trouble for people in math. Because once you write something down wrong, it's really hard to find a mistake until you get to the end sometimes. I wanted to go over what I want to go over changes base. Okay, let's condense one. base 4. Right, so let's condense it into one logarithm. So first of all, we can take and put those two together on the inside using the quotient rule. So that's log base 4 of x over log base 4 of y. And then that is going to, oops, sorry, one log, I'm sorry. So we're putting them together into one log. And it's x over y. And then this is going to come out and be a power. And then we can take it and put it into radical form as q base plus 4. Right. So that's a condensing. One back to the other. I think the expansion is a little bit harder, but the condensing is going back the other way. Let's try one of the change of base things. All right, so remember, the change of base remember it's log, and then you b to the l. And then the m goes up top side, and this means you use the new base. Same base down here with the b. So that's what we're using. So let's say we're wanting to do evaluate and this is the strange, this is a kind of funny one. In theory, you could have this kind of base. This is an irrational base pi, but so is e. And I seriously doubt that you got anything that could calculate this on the calculator. You might be able to if there's a way for you to choose the base. So this is going to be, and let's just use the natural log. I'm sorry, the common log. And we'll work with the natural log. So that's pi, all right? So let's just evaluate each one, and I'm going to write it out. Okay, again, the calculator has a regular log, so there's 3.14 log, and I'm going to put that into the memory, and use 400, and hit the log. So this is, and I'm going to write it up here, 2.60. 6, 0, 2, 0, 1, and then the bottom, and then divided by, and then recall, which was 0.49715. So that's going to be approximately equal to 5.2. All right, so that last thing right there is very important if you've got bases that you don't, are not able to evaluate, and you can generally convert them to common logs or to natural logs with which the calculator can easily do. Like I said, there may be a way on some scientifics to evaluate some other base log, but I don't even know it. I don't really even care if you can do this. Okay. All right, so that should be enough for today. If you got any questions, let me know. Like I said, is just realize